Good day once again. My name is Graphics. Today we'll be looking at pure substance. Now, what is pure substance? We'll say pure substance is one which has a uniform physical structure and fixed in chemical composition and is said to be homogeneous. Now we have examples of pure substance. One example we have is water. Another example is helium. We have gold, we have sodium chloride, and so on and so forth. Now, what do we mean by saying a pure substance has a uniform or fixed chemical composition? Now, we talk about, you said uniform fixed chemical composition, right? Why would we say water, what would say a pure substance must have a uniform or fixed chemical composition? Let's take example now. A container that is filled with air, right? We know air is a mixture of gases, and two of the major components of air is what? Oxygen and nitrogen. Are we good? Now let's consider this container that is filled with air. If I take a pocket here and I realize that I'm having 80% of oxygen, right? And I'm also having 20% of nitrogen in this pocket here, in this region. And I also take another region, a pocket here, and also realize the same percentage, which is 80% oxygen and 20% nitrogen. Now, you say that what? This is a pure substance because of what? The chemical composition here, they are what? They are uniform, right? And it also shows that what? Pure substance can be made up of what? More than one element or compound. Are we good? So that is for one condition. Now, you must also know that the condition 2 that we have, condition 2, is that a pure substance can exist in a single state or more than, in a single phase or more than one phase, right? For instance now, let's consider water. Are we good? Now, at the base of the water here, let's assume this is the solid region, which is the ice, and on top of it we have the liquid part of the water, which is what? The liquid here. Now, at solid state, water is what? H2O. At liquid state, water is what? Also H2O. Are we good? So you see that the composition of it is what? It's fixed. It has a fixed, it is homogeneous also, because at any of these states, this phase, water is what? Has the same chemical composition, which is what? H2O. Are we good? Now also, let's consider a piston cylinder arrangement which contain water. Now this is my cylinder, and this is my piston that I section here. This is a section view of a piston cylinder arrangement. Now in this my cylinder here, this my piston cylinder arrangement, it contains water. Let's say the water is at temperature of what? 20 degrees centigrade. Are we good? Now, for this piston to be in equilibrium, if there is an atmospheric pressure acting on this piston, right? This is the atmospheric pressure acting on the piston. Now, for it to be in equilibrium, there must be an equal and upward force that is trying to what? Balance this what? This pressure, right? Let's say the pressure is what? The pressure is 1 bar. So we say that at this state 1, my pressure is, my P1 is what? 1 bar, and what? My T1 is what? Is equals to what? 1 bar. Is equals to what? 20 degree centigrade. Now, if I heat this container, you will notice that the temperature will increase, right? And the specific volume of soap will also increase. So the temperature of it will what? Will increase. Let me say it increased to the T2 here will be equals to what? 100 degree centigrade, right? And my specific volume also will also increase. But my pressure T2 will be constant. That's, let's say, still 1 bar. Now still, it will try to balance the atmospheric pressure that is coming in, which will say it is also what? 1 bar. But the temperature of my liquid here has increased. Are we good? So as it increases at this state here, this is also the liquid state, but we'll call it saturated liquid, right? This liquid state, because we know one thing, that when there's an heat addition, when heat is added into a substance and that heat tends to what? Increase or reduce the temperature of that substance, that heat is said to be what? Sensible heat. We'll call it Qx, right? So now this is 100 degree. Now at this state here now, what happened? It will absorb latent heat of vaporization at this state. When you further heat this container here, when you heat it, what happened? It will absorb. At this state here, this is still the liquid state, saturated liquid, because the temperature of here has increased and the volume here of the specific volume here has also increased. So if you further heat this container here, this piston cylinder arrangement, what happened? The temperature will also remain constant at this point here, because when there's a phase change, temperature is always what? Constant. But what happened? It will absorb latent heat of vaporization, and when a liquid absorbs latent heat of vaporization, it automatically turns into what? The vapor state. So at this state 3 here now, at the same constant pressure, the liquid, the saturated liquid, has turned into what? Saturated vapor. Are we good? Saturated liquid has turned to what? Saturated vapor. At the same T3 here will still be 100 degrees centigrade. The pressure P2 here, P3 here will be equals to what? Still the 1 bar. Are we good? So at state 3 here, it is saturated. It's a vapor, saturated vapor state. Now, if I further heat this vapor, what happens? It will move into my superheated steam or my superheated vapor. But here now, if I further heat this vapor at this state here into a temperature, let's say T4 will give me 200 degrees centigrade, but my P4 still remain what? Constant, which is 1 bar, right? So now we'll be having what? Saturated vapor state at this point here at state 4, right?